So I'm going to just begin with the example that we kicked off with when I taught polynomial long division, which was x cubed minus x squared minus 14x plus 24 divided by this whole thing x minus 2. And when we did long division, the result we got was x squared plus x minus 12. So we know that's what we're trying to get to with this new technique. Now, the approach for synthetic division is we draw this half rectangle and we begin with the question, what value of x would make this 0? And hopefully it's clear to see that would be 2 because 2 minus 2 is 0. So we write the number 2 outside here. The next step is to then write the coefficient of each term in the dividend, the thing that we're dividing into. And the coefficient of x cubed is 1. The coefficient of x squared is negative 1. The coefficient of x is negative 14. And then the coefficient of x to the naught, or the constant, is 24. The next step is we bring down the first coefficient, and we write that beneath the half rectangle. And then the number outside, this number here, we multiply by the number beneath the rectangle. So what is 2 times 1? Not a trick. 2. Good. So we write 2 here. And now we add the two terms. So what is negative 1 plus 2? 1. So we write that down here. And then we repeat the process. So now we multiply 2 by this number, which again is 1. 2 times 1 is 2. And then we add up the two numbers. Negative 14 plus 2 is negative 12. Now we take the number outside 2 and multiply it by negative 12. We get negative 24. And 24 minus 24 is 0. And that's where we stop. Now, the way that we can interpret this synthetic division process is each of these numbers that end up down the bottom represent something. So the first number represents the coefficient of x squared, then the coefficient of x to the 1, then the coefficient of x to the naught, and this final number will be the remainder. So taking that, we would know that the result of this division will be 1x squared plus 1 of x minus 12 with no remainder. And notice that is the same result as what the long division process gave us. So that's the mechanics of the process. Many people will look at that, and if they compared it to the long division algorithm, this is much quicker. Like there's a lot less going on, a lot less room for error, because in the long division algorithm, you're constantly subtracting a binomial term, like two terms, and all of those double negatives can really result in little tiny errors. And so many students will look at this and go, I like that. And so in the situations where this can work, it's preferred. But there are a few caveats, the first one being it doesn't always work, and so I'll talk through that. The generic rule for knowing when will this work, the thing that you're dividing, in other words, the divisor, must be in the form x minus a, where a is the constant. So you can still have x plus 2 or x plus 3, that just means you're minusing a negative, but it has to be in that form, and what that really means is it has to be linear, so the power of x has to be 1 only. If you try to divide x squared minus 2, you're going to hit problems. It also means the coefficient of x has to be 1. So if you tried to divide 2x minus 3, for example, you'll also hit problems. And what I might do, one of the examples we did with long division actually had a divisor of 2x minus 3. So what I'll do is I'll work through that example, because we already know the answer from long division, and I'll show you what synthetic division spits out, and we'll see that it's not right. And that should hopefully be enough to give you an idea of what's going on. So the next example I'll work through, we were taking 4x cubed. It was minus 19x plus 9, and we were dividing 2x minus 3. And the result that we got from long division was 2x squared plus 3x minus 5. But we also had a remainder of minus 6. So that remainder, because it never got a chance to be divided, it's minus 6 over 2x minus 3. It still needs to be divided. Now, the first thing to note is with the polynomial long division algorithm, because the question skipped the x squared term, we need to just pop that in there. But basically we have 0 of that x squared term. But we need all of the terms of the polynomial for the algorithm to work, and that's also true for synthetic division. You would need to write the 0x squared. But in terms of just following this algorithm, we draw up our half rectangle. We ask ourselves what value of x would make the divisor 0. And if we think about that, we'll see that that value is x equals 3 over 2. And already the fact we get a fraction kind of raises some alarm bells. But following the method, we would write 3 over 2 outside. And now we will write the coefficients of each term in the dividend. So we have 4, 0, negative 19, and then 9. We bring down the first number, and then we multiply 3 over 2 by 4. So 3 over 2 by 4 would be 6. Then we say 0 plus 6 is 6, and then we repeat. 3 over 2 times 6 would be 9. Minus 19 plus 9 would be minus 10. And then 3 over 2 times minus 10 would be minus 15. And then 9 minus 15 would be minus 6. And then, as we saw before, each of those numbers at the bottom represent the coefficients of the terms. So this algorithm would say that the result would be 4x squared plus 6x minus 10 minus this 6 represents the remainder. That never got a chance to be divided, so we keep the minus 2x over 3.
So if you can just divide everything by 2 because of the remainder.
Very good. Good noticing. So notice that in this first section of the answer, it doesn't match the real answer. It's all out by a factor of 2. But the remainder wasn't. The remainder was actually spot on. So it's a bit mixed, isn't it? So you could ask yourself, I wonder whether all I have to do is follow this algorithm and make some adjustment, and will that always work? Here the adjustment would be everything's doubled, so I just need to halve all those coefficients except for the remainder. Would it work if it was a fraction that had 3 in the denominator? Would everything be tripled and so I just have to do it by a third? Maybe, maybe not. But at that point, you have to ask yourself, is this algorithm with those adjustments actually now simpler than just always knowing that the long division algorithm will work? Again, it's really a choice that only you can make for yourself. It depends on what you think is easy to follow. So I know for me personally, I would just get really good at the long division algorithm and just make sure I don't make mistakes. And that way I don't have that extra cognitive load of trying to think, is this other approach going to work? And if not, how do I adjust it? I think in the end, for me, I would probably find it quicker to just go right away, I'm using long division. I'll just learn to do that efficiently and swiftly without error and kind of carry on happily.